All right, let's go ahead and get started. Thanks everybody for joining. Today is a Privado webinar on getting started with privacy scanning. So we'll go over kind of what the benefits are of scanning your source code for privacy violations, privacy risks, things like that, and then do a little product demo at the end as well. So just to kind of set some initial context here, my name is Ben. I'm the principal product manager here at Privado. I was previously at a company called SourceGraph, which focused on code search and developer tooling. So semi-related in terms of the code scanning space. And our agenda today, like I mentioned, is kind of go through privacy engineering gaps and how code scanning benefits those, the proactive versus reactive approaches to privacy, how to embed that into product development, and then we'll do the demo and then have a Q&A. And if you do have any questions, I have the Q&A open, so feel free to pop questions in there, and then as soon as I see them, I'll try and answer them. So when we talk about the gap between privacy and engineering, we're really looking at three kind of main components from our perspective, which is that data processing is distributed, data flows change with every release, and there's a lack of governance on data usage. So the way that kind of plays into the day-to-day is that you've got all this data happening, or this data processing happening across different services, applications, APIs that may be calling out to third-party systems. You're developing product very quickly, so the data flows are going to change regularly, sometimes potentially multiple times a day. And then there's a lack of governance on data usage. I'm sure lots of us have seen this happening where you're maybe putting accidentally PII in a Google Sheet, or you're doing some integration with your CRM that has PII data, and it's sending that to some other third party. So there are challenges there on visibility into how the applications are collecting, storing, and sharing the data. It's really difficult to implement privacy by design because the code is changing all the time. And then you're going to have an inability to meet those privacy commitments, leading to increased risks and misrepresentations of what your posture is from a privacy perspective. So we try to take a proactive as opposed to a reactive approach to privacy. That means scanning at the start at the source code level. So we can address those risks at the source level, which means you can detect potential violations, leaks, unauthorized sharing before those changes ship to production. So that gives you a huge advantage in terms of making sure you're not susceptible to privacy violations, privacy leaks, things of that nature, because you can detect them before the changes occur and are pushed to your production app or any production version of internal systems as well. So the other approaches are kind of the process level, where we see a lot of people doing manual data maps, things like that, to get a sense of what they have out there and what their data inventory is at the data store level. Those processes are fine and good to do, but you're going to find yourself in a situation where the data maps are out of date very quickly because you're releasing fast, and you really don't know necessarily that the data map you started creating a month ago is going to really be relevant to the current state of your reality. And even at the data store level, you'll have data you may find that is PI being stored you weren't aware of, but without mapping to the source code level and getting an understanding of how that data is being processed, you don't really know how it's getting there. And so the code scanning approach really gives you more visibility into that as well. So here we can see kind of high level, what are the benefits of embedding privacy into product development with the privacy code scanning approach. And so we'll go through some of these examples, but you can see you can discover and classify personal data. It will give you that data flow visibility, finding and fixing privacy and security issues. So, as you scan, generating issues where there are violations and things you need to take a look at, and then the monitoring continuous privacy compliance piece. So the first thing I want to go through is the data flow visibility. So the code scanning lets you get data flow visibility into your third parties, into your databases, into any logs you might be leaking PI to, without having to do any API integrations, even aside from the integration with your code host. So we can scan your source code and get all this information and the data that's going to these individual third parties. We don't scan the data directly, but the application source code will tell us what data elements are going into these individual third parties, databases, logs, etc. We do automatically classify personal data as well. So these are customizable if you do need to have custom data categories, but we start you off with some of the more standard ones. And the code scan just picks that up automatically. So we detect these data elements in the code and then classify them based on where they go in our classification hierarchy. And then finding and fixing privacy and security issues. So those scans will generate things called issues, which are basically, as you can see here, like first name shared with HubSpot for example, and then it'll give you a description of that issue, what the suggested fix is, and even show you the line of code where the offending leak or sharing is occurring, so that your engineering team can have an easy way to get the context they need and be able to fix that, remediate that issue as quickly as possible. And then monitoring continuous compliance. One of the ways we do that, aside from scanning in the background consistently, is integrating with GitHub. And so as you're pushing changes to your different pull request branches, or just pushing changes up to your code host, we'll be able to run those scans as those requests are created automatically. And so you'll be able to detect any of those violations before something gets put into production, kind of like we were talking about earlier, where you're able to just prevent that from happening. So you can see here what's happening is the Bravado integrator is just making a comment on this pull request saying, hey, we found account name and first name in the code change you just pushed, giving you an awareness that happened, and prompting you to fill out an assessment to explain what the usage is or the purpose of processing is of that data. So just kind of summarizing then, when we talk about scaling privacy and accelerating innovation, the use cases really, as we kind of mentioned before, are data mapping and assessments. So automating the data mapping piece, where the assessments, like you just saw, will be created as the privacy violations are detected. And then that lets you really kind of, as you need, do on-demand assessments instead of kind of doing them on a schedule where you're doing assessments every 3 months, whatever, and maybe catching something, or maybe making someone like an engineer do work that's unnecessary because nothing has changed. This lets you automatically find out when there has been new data added to the code base or to your data schema, and so you can get a better sense of when you need to do assessments and only do them on demand. Finding and fixing those shadow data flows. So it's really difficult to know, like I mentioned, when you're doing the data mapping exercise, where data is coming from if you don't have the source code scanning done, because you won't have any sense of where this processing is occurring. The data store is not going to tell you any information about how the data got there. It's going to tell you what it is. So this really exposes, the code scanning really does expose all the different data flows from the processing perspective, and where your applications, internal and production, are sending the different data elements to. And then that continuous privacy by design lets you really build the privacy practice into your development lifecycle, because you're able to monitor and check all these things basically continuously. So rather than doing spot checks with assessments and data mapping exercises that you're doing manually, this is just integrated fully into your software development lifecycle, into your SDLC. So here's some of the metrics we see from customers at Bravado. So people are able to complete data maps in as little as 3 days. We hear from our customers that this can take, sometimes 6 to 12 months to actually complete a project, depending on the size of your organization and the complexity of your systems. We do find on average, about 100 plus log leakages or third-party sharing found. So that can be really relevant if you're just not sure where your data is going. Log leakages are typically a bad place to have PII stored, because a lot of people will have access, like maybe the whole engineering team, and logs tend to persist for a long time, so they can stick around for quite a while, and you may have stuff sitting there you're not even aware of. So being able to detect what PII is being sent to those logs can be really valuable right off the bat, just give you a sense of where you need to look for PII. And then we see a big time savings executing privacy checks. So again, those kind of assessments and data mapping, all those kind of things you're doing to validate and understand what your privacy posture is, that turnaround time is just much, much faster with Bravado, because we're automating so much of it away. So with that, I'll take a look at the product demo and kind of walk you all through some of the features we've got in the product. So here's our dashboard. You can see it's kind of empty here because we haven't run any scans lately. But if I look at repositories, you'll see all the different repositories that have been scanned. So if I take a look at this Shopweiser repo, it's a open source e-commerce application. But you can see with the data flows we've got here, all the different categories of data flows that are happening. There's data elements that are detected by the code scan. So you can see here, hopefully that's visible to everybody. I just zoomed in a little bit. You can see here all these different data elements that detected, and then showing you where the data flows are. So if I look at, say, language preferences, we can really get a sense of every place that language preferences are going. So you can see here it's quite a bit. All these different third parties are being shared to. There's the sales manager database, which is just the database for this application. Lots of log leakages, not ideal. A lot of processing, which is just kind of where that data is being used in the code. And then collections are internal APIs to that application or to your system, like other repositories where the data may be sending it to, like an internal service or something like that. And then we do for each of those have the code analysis. So again, this is more for the technical users like engineers, but you can get a sense of like, okay, this started here, and then here's the sync where it's going. This transaction, get transaction details, sending the transaction details here. So that's basically kind of what that looks like. And then inventory will show you the more details about the third parties. So that's at the repository level. One of the things I want to show that is really critical here is you can do this across your entire system. So this is showing every repository that was scanned, what we found. So you can see here found in like say 11 repositories, or in this case, 10 repositories, we found email address. So if I look at this, here's the Shopify repo again. I want to click on data flows and look at where email address is going. You can see again, all these different places. So quite a bit of sharing happening, lots of log leakages happening again, and a lot of collections, which collections aren't necessarily risky, but you may want to know where data is going inside your system. So you can take a look at that as well. And then if we look at the assessments, let's just take a look at what that looks like. What happens is, as you're doing these code scanning, you'll get, like I said, an alert to tell you that you need to fill out an assessment if new data elements are detected. And the difference between a Privado assessment and other companies' assessments is really that we automate a lot of this. So you will have some questions in here like you'd expect from a normal PIA or DPIA or a ROPA. But we do pull out, for example, here you can see all this data that is being used. We don't require the engineer to go in and manually remember or hunt through the code to find out what PI is being used. I mean, they may not even know what PI is or what PI you care about. And so this really lets them just kind of become an editor and a reviewer rather than having to be more actively engaged with the process. They can just kind of say, hey, let me see if this makes sense. If I look at this language preferences again, here's the code where it's being shared. Here's that sharing again, like we saw previously. But this lets the engineer really get context quickly and just kind of be like, oh yeah, I remember where in the code this is happening. And because we point them directly to it, it's a lot easier for them to do this quickly. And it can take weeks sometimes, if not longer, for engineering to get back to you on these things, because it is such a drag to kind of go through and do them manually. So close this out. And then if we look at the policies, kind of how you might create those policies to get the issues generated, you can see here we've got a variety of credit card policy, no SendGrid exfiltration. So this will just basically, using only last 3 digits of credit card as the recommendation here. And so you can see, you can kind of define these, give a description, and help engineers understand why the issue was created when they see that comment on GitHub. And then reports is basically kind of your regulator style data mapping. So what we have here is basically 1 row per repository. So you can see we've got all the data categories, the data processors listed here, and all the data that essentially a regulator is going to be looking for, you can fill in and modify on the repository page and through assessments. And this is automatically kept up to date. And we also integrate with OneTrust. So if you're doing OneTrust for your ROPA assessments or your PIAs or DPIAs, you can pull that data into OneTrust or push that data into OneTrust and sync it back and forth. So they'll always be up to date rather than having to do these manually. So I think the next thing I want to show you is a little preview of some of the things we've been working on. So this is our new issues feature. So you'll see here what we've got is categories of data. All this has been generated by code scans. So you can see here we've got like sensitive personal data, password leaked to access log, gender shared with HubSpot, first name shared with HubSpot. And if I click into one of these, you'll see again that description of the issue, what the recommended fix is, and that code line that you want to show the engineer, or the engineer will want to see to be able to understand where this is exactly is happening. So really helpful to be able to group and sort those issues and be able to identify certain categories you may or may not care the most about, and get a sense of what the issue severity is, et cetera. And then our contract scanning feature is basically a feature that allows you to scan DPAs and pull in vendor contracts so that you can see what data categories, for example, or purposes of processing you've got. So in this case, what you do is upload a DPA, a vendor contract. So in this case, I've got Slack, and you can see here it's pulling in data subjects, data categories, purpose of processing, et cetera. And then the way we link this to the code scanning is basically we'll say, okay, we've got this third-party link for Slack. We know about Slack in the code scan. And then if I click view now for this element we detected, you can see here we found the scan basically matches up, the contract scan matches up with the code scan, and then detects this undeclared category, financial data, that was not detected in the Slack DPA, but was found in the code scan. And so that lets you kind of sync those two together, so you can align what your contracts are saying with what your actual code is doing inside of your applications, inside of your systems. So that's it for the demo. Now we have time for some Q&A. If anybody has questions, I'm happy to take those. Okay, we've got just one question. FTC recently fined Premom for sharing health data, which was not there in privacy policy. Can you help with that as well? Yeah, so I mean, the Premom case, I think, is a good example of third-party sharing where that most likely could have been prevented by taking a look at data flows, which we saw here. For example, you've got that sharing out to third parties. So it'll list for you what vendors are being shared to, and then also what data is being shared to them. So you would detect that easily using the issues feature and then be able to visualize it in the data flows. So yeah, I think this is one of the great examples of being proactive there. Is if they were doing code scanning, they probably would have been able to prevent this. We've got another question. We use data discovery tools. What additional protection does code scanning give? So yeah, again, on that proactive piece, we're really looking at making sure the data sharing is detected before it gets shared, whether that's to a database or to a third party or to a log. This source code scanning really prevents that from happening because you can at least review it before these changes are made. We have the GitHub, GitLab, and Bitbucket integrations that let you monitor those changes to the source code to make sure none of this stuff happens and get alerted if there's a risky change about to occur. Whereas on the data discovery end, you're basically looking through data to dig up stuff you've already got. So it's kind of, the chicken's already flown the coop. So you've got to go in there and figure out how to get that out, but then you still don't know where it came from. Next question is, how is Bravado solution different from traditional source code review tools used during security review? So I mean, I think that question is asking more about like static scanning for security vulnerabilities specifically. So the underlying technology is actually a little similar. We do use some static analysis, but we do a lot of other things as well on top of that. I think the static analysis tools that are typical you see in traditional security reviews are looking at things like SQL injection, stuff like that are more technical and abstract. And so they will detect those as well. This is more focused on the privacy issues and really getting that data flow and understanding of the full system flow to understand how the data is moving through the system, where that offending code is happening, and being able to remediate those issues. So it does a little more than I would say than what the security vulnerability scanning does, but it is in some ways similar. Next question is, what is the first effort needed to implement the solution? So really, it's pretty simple. We require an integration with a code host, so GitHub, Bitbucket, GitLab. We support all the versions of those. There are like enterprise versions and on-prem versions. But basically, we just need your help to select the repositories that you want scanned, and then we start scanning, and then the dashboard will start populating, the data elements will start populating. You'll see information coming in the product right away. So, depending on how quickly we can get access to your code host and have those permissions set up, same day, really, you can start seeing results. Any help with GDPR documentation? Could we maybe clarify a little bit what's meant by help with GDPR documentation? I think the one thing I can show is if we look at the reports here, so like documenting for, ROPA reports, exactly. So yeah, let's go back to assessments again and take a look at this. So for example, we've got this assessment for a ROPA assessment for this Shopweiser repository. So this is, these are customizable intake forms, but we have the questionnaires here. And then what's happening is this is based on the code scan. So again, this data is pulled out automatically for the developer or whoever's filling out the report. So you don't need to go in the code and hunt down what PI is being used. We pull that out for you. So you're able to review easily and see what is happening in the code. You can look at the data flows as well and see kind of how it's being used more visually. But then when you submit this, essentially what happens is we baseline the ROPA report, and then every additional ROPA report has the data that was given previously pre-filled. And so instead of filling out the same ROPA every time from a blank report, you're doing it incrementally. And then, as I mentioned, I think on the GitHub integration, you'll get a link to a much smaller version of the ROPA that just asks you to fill in what data was the new data, purpose of processing, and things like that. Steve is asking, what languages can we scan? So we support really every major programming language. The one limitation is the data flows specifically. So we support dozens of languages on the inventory side. So when you're talking about just getting all the data elements together, like what are you processing? What are the third parties? What are the databases, et cetera? That works for virtually any language. It's literally dozens of languages. All the major ones are supported. And then as far as the data flow piece, right now it's Java, Python, JavaScript, TypeScript, and then Ruby and Go are in the works right now as well. Okay, another question is, how often do we update ROPA reports? We're refreshing it annually at the moment. What's the cadence in Bravado? Yeah, so the cadence in Bravado is basically, you'd fill out an initial assessment, and then from there, the prompt will essentially say, I want to look at new data elements as they're detected. So if I look at like repositories, I think I have a good example here. Like I don't have, what'll happen is like in this Shopify repo, for example, on data elements, like a little up arrow and like a 1 or a 2 will show up saying there was 2 new data elements. And that's then you'll get a prompt to fill out the ROPA again. And as I mentioned, I think the data will be pre-filled from the last report. So basically you're getting an update saying, hey, you should probably fill out an assessment. A new data element was detected being processed in this repository. But you don't need to, you can do them manually anytime you want, but Bravado will help you basically save time by only triggering an alert to do that when there is new data to be assessed again. Okay, I think that's it. We'll call it there. Thanks everybody for joining. Last thing I'll note, if you do have any questions, feel free to learn more at bravado.ai/schedule-demo. I'm happy to give a demo to anybody who's interested. And then, we'll see you with the next one. Thanks.